Question B2. This question is about alpha particle scattering. An experiment is carried out in which alpha particles of initial kinetic energy 5 mega eV are fired at a piece of gold foil. The proton number of gold is 79. Determine the distance of the closest approach of alpha particles to a gold nucleus. So what's actually happening here? Firstly, we've got alpha particles. We remember that alpha particles are basically a helium nucleus. It's made up of 4 nucleons. So an alpha particle has got 4 nucleons, 2 protons, and an alpha particle is a 2 plus. So you have an alpha 2 plus going, and it's moving with a kinetic energy of 5 mega eV. So that's 5 times 10 to the 6 eV, and it comes and approaches a gold nucleus. So gold is Ag, or is it Au? Ag, I think it is, and that's 79 plus. So now, if it comes head on like this, what's going to happen is that the alpha particle is going to come in, and only for a very small proportion of them, they're going to head straight back again like that. These are the alpha particles that are going to come closest to the gold nucleus. And at this point over here, at a certain point where you have got a distance d, a minimum distance d, you have your Ek equals your potential energy. At a certain point it actually stops, and they get potential energy, and therefore then they shoot back, and that is converted back into kinetic energy. Now your kinetic energy is given by this over here, so that's 5 times 10 to the 6 eV, so that's times 1.6 times 10 to the negative 19 joules. That's the kinetic energy that it has. So that's your Ek. But what about your EP? Well, your EP is given by this formula over here. Actually, I will just work over here. Let me see if I can take that out here. Your EP is given by this formula, and basically you need to know this. It's Q1, Q2 over that distance. In high level we discuss this in more detail. So this EP is equal to the kinetic energy, so it's this over here, 5 times 10 to the 6 times 1.6 times 10 to the negative 19, and that's equal to your K. Now the K is equal to 9 times 10 to the 9. That is your Coulomb's constant. You can get that in your data booklet. And now you've got your Q1. This is your, we could say this is your alpha particle, and this is your gold nucleus. Now the charge on the alpha particle, the Q1, is going to be 2e, so it's going to be 2 times e times 1.6 times 10 to the negative 19, and the charge on the gold nucleus is going to be 79, because it's got a proton number 79, so it's going to be times 79, and that's also times e. So this e, 1.6 times 10 to the negative 19, is actually going to be squared like that, and that's all going to be over d. And so your d is going to be this over here. Now one of your 1.6 times 10 to the negative 19 will cancel with that, so that's going to be 9 times 10 to the 9 times 2 times 1.6 times 10 to the negative 19 times 79, and you're going to divide that all by 5 times 10 to the 6. And when you do that, what you should get out of that is you should get 4.6 times 10 to the 14 meters, negative 14 meters.